This is Group 2's presentation on shift registers. Another very important circuit that is built from flip-flops is a shift register. Without shift registers, computers wouldn't be able to multiply or divide, nor would computer networks be able to exist. With a shift register, if we want to multiply a number by 2, all we have to do is shift it to the left one place. If we want to multiply the number by 4, we shift to the left 2 places. And if we want to multiply the number by 8, we shift the number left 3 times, and so on and so forth. Dividing a number can be achieved by doing a similar technique, but in the opposite direction, to the right. A shift register is a synchronous device with no ripple effect. This means that the clocks for each register is connected, so they are operated at the same time without missing a beat. In order for shift registers to be able to multiply and divide numbers, it has to be able to store information when inputted. One way this shift register is able to take in and send out information is called parallel in, serial out, meaning that the bits or information inputted is parallel, but sending it out to another device means that each number is taken one at a time. Here's the chip diagram for the shift register chip, also known as the 7495 chip. For this presentation, we will be building a parallel in, serial out circuit. Here we have a built shift register circuit. We have our inputs coded as blue and green. We have our power, 5 volts, labeled red, and our ground, which is black. And our inputs for both chips are yellow, going to the logic indicators. For how this circuit works, we have our clock inputs 8 and 9 put together and connected to the debounced push buttons, so that when this button is pushed, the result for both the chips work at the same time. Currently, all of our inputs are low, and all of our logic indicators are also low. Let's see what happens when we input something like this. Every other input is low. So when I shift this by pushing the PB1 button, that corresponds with the logic indicator, which matches the current input. The system or the circuit was able to read the inputs and copy it to the logic indicator from memory. This is how the shift register circuit works. This is the end of the shift register presentation.